Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome to Happy Path Programming. We got a good one today. This is going to be fun. We've got Gunnar. Gunnar, what's your last name?
Hey there, Gunnar Morling. I'm Gunnar Morling.
Awesome. So we're going to talk about your 1 billion row challenge today.
Right.
But before we dive into that, let's talk about the Winter Tech Forum.
Yes, because this will probably be the last reminder, because I'm going to be traveling for the next 2.5 weeks or so. So we're not planning on doing
You'll be out in the Bay Area in California.
I'll be in the Bay Area and then LA.
Wants to meet up.
Oh, that's true. Yeah. So make sure you sign up early. Make sure you actually register early
for the Winter Tech Forum.
For the Winter Tech Forum.
Crested Butte, Colorado.
Yeah, so go to wintertechforum.com and you'll find all the information there. And it's the website's pretty extensive, so if you're worried about, well, how would I get to Crested Butte and what else is going to happen, we
it's all
try to be
there.
Pretty clear. Well, hopefully pretty clear there. And
when you sign up, you'll get access to a Slack channel where you can then
ask questions, join people for car rides up, and also if you just are coming by yourself, there's a way to use the train and the bus from the airport, which works really well. So all the information's there. The important thing is that you sign up soon enough, because a couple of weeks before the conference, I have to release any unused tickets to the Friday night ski to the yurt dinner and everything. So if you don't get in time, you'll miss out on that. That will not be. We won't have a ticket for you because I have to release the.
And you don't want to miss that.
And you don't. Oh, yeah, that's always really fun. And I've heard, we've got a decent amount coming, and I've heard, Diane might come.
Oh my gosh, that would be amazing.
Yeah, it would be. So it's
been a while since she's come.
It has been a long time since she's come. So that's always fun when Diane's here. So
this is Diane Marsh. We had her on an episode years ago.
Yeah, she's a director at Netflix, and she co-authored the Scala book with me and everything. So
nice.
I first learned Scala from her talk at the Sandusky, Ohio conference.
That's amazing because I realize now how little we knew when we were writing that book, and the fact that you know it so well now is very much of an inversion.
Yeah.
So, all right.
Okay.
Yeah.
So, and that's February.
The last week of February. Ends the last day is March 1st of the official conference, but we do things before and after the conference as well. So that's all on the website.
Yeah. And maybe we'll do a session on the 1 billion row challenge.
That would be amazing.
Look at some of those. Okay, well, let's kick it off with Gunnar. So, Gunnar, you welcome. Thanks for joining us.
Thanks so much for having me.
So you did this crazy thing, which I think maybe you didn't expect to go quite as crazy viral as it did. But this is just a few weeks ago, you announced the 1 billion row challenge.
Right.
And I'll give my impression of it, and then you can give us some details.
Totally,
so the idea, from my understanding of the 1 billion row challenge, is there's going to be a file. It's going to be large, like 13 gigs.
And you created that file, right?
He has
yes, there's a generator, so people can create it by themselves, because I just don't want to upload like a 13 gig file. But yes, I have one which I use for evaluating all the entries.
Okay.
And so there's this file that has kind of like weather station temperature readings, and there's a billion rows. And the goal of the challenge is to see how quickly you can read the file and then assimilate a summary of the weather station data into min, max, and mean of that data. And so you announced this, and you provided an easy implementation as a reference of like, okay, if you're doing this in the way that you would normally think about doing this, here's an implementation. And it turns out, as expected, that that's maybe not the fastest way to do things. So give us a little more detail on the billion row challenge. Why did you do this?
And what possessed you?
What? Yeah, that's what I'm trying to figure out myself by now. What did I do? I don't know, to be honest. I'm not even sure. It was over the holidays. I had some time at my hands between Christmas and New Year's Eve, and somehow I had this idea to do something with a 1 billion rows for quite some time. I felt obviously it's a nice round number. I feel it's a size of data which takes you a little bit longer to process if you do it naively, but then also you can, take it and make it quite fast. So I felt right now for the compute power which we have at these days, it's a interestingly sized amount of data. So yeah, I thought, let me see what I can do with that. And then I just felt, okay, I want to put out something for my friends, like people I interact with on social media. And I thought, yeah, maybe a handful of people will like react to it and participate. And I was actually talking to my wife about it up front, and she's smarter than I am, obviously, because she said, you got to put something in there so that you are not overwhelmed with too many people participating. Whatever. It's going to be fine. I want just people to participate.
Yeah.
And luckily, I put one thing in place, and this is, it's got to be in Java, right? And you don't have to use dependencies because I just, I'm not super familiar with like Rust and all on other languages. So I wouldn't, it would take me a long time to like set up the environment and like to compile the stuff. So I felt, okay, I want to narrow it down a little bit just from an operational perspective.
By not using dependencies, it kind of prevented people from cheating in a way where
exactly.
you could maybe write a C program and then use JNI
right.
and wrap that into a library. And all of a sudden your Java program is one line of code that just like calls the C library. And that wouldn't be that's not along the lines of what you were trying to look at.
You were really trying to exercise Java.
Right, because so that's, it's close to my heart, and there's so many new APIs and developments in the platform. Like there's, an API upcoming for vector computation, so you can use all those nice SIMD instructions of your CPU. There's new APIs for interacting with native memory more efficiently, all this kind of stuff. And the primary motivation for me really was to just, have a nucleus for people to play with, to also explore those things. So actually this leaderboard which we have, to me, it's not the most important thing. So I'm not that interested like which one is the fastest. It's just really meant as an opportunity for people to learn, to exchange with others. So for instance, it's in particular it's legal to get inspiration from other people and see what they do. Of course you shouldn't like resubmit just another entry. I mean, that wouldn't make any sense, but you should, it's totally fine to take inspiration and learn from that. So that's the main goal, and that's why it's also focused on Java, because that's
what was cool about this was we have people that are extreme experts into performance optimization problems, and I think oftentimes these people are they're working in an organization and they're not often sharing this expertise with others, and so creating this mechanism where people are essentially sharing the approaches that they would use to do these kinds of optimizations is some really interesting knowledge that is not often shared. And so I think that was one of the super cool things that came out of this.
Right. And I mean, lots of actually really well-known people from the community participated, like Alex Shipulev and Cliff Click and like all those people, right? So this was, of course, also very fascinating for me to see that all those people would actually, be inspired to participate. So it seems,
I mean, one of the top entries, from what I remember, is from Thomas, who's like I don't know, runs the Graal VM team or something like that. So to have somebody who's a real deep expert on the optimizations in Graal VM and Java and them creating an entry, there's so much that we can learn from seeing what people have done there. So
absolutely.
Super cool on that front. One interesting side note is that this certainly exploded beyond the Java community, and you've seen implementations now in every program, every major programming language.
It's really wild. So I mean, we have it was actually an idea from a colleague of mine, Robin Moffat, to create like this show and tell section. So it's all on a GitHub repo, and there we have like a discussion section now where people just can bring their alternative implementations not as an official entry into the challenge, but just for them to show off and interact with others. And yeah, there's like C, C++, Rust, .NET. Somebody did it in COBOL actually, like the other day.
Oh, that's impressive.
Yeah, it's brave.
How did that one do performance-wise?
I haven't seen the number, to be honest. And he did it single-threaded, so I guess it's not super fast. But yeah, so there was that. People did it in Org, and then also all kinds of databases.
One, of course.
Scala, of course. I suppose like Kotlin as well. And so, also databases like Snowflake, Postgres.
Oh, that's right. Yeah, people were doing it with databases.
What about, because it seems like Julia would be a really good fit for this, or Python has these highly optimized math libraries. Have people done it?
Yeah, with Python for sure. And I also think I saw Julia. I would have to go to the show and tell to be sure, but I think I've seen it. Yeah, yes.
Yeah. So lots of different implementations that we saw. And there was some interesting competition between, I think, the C# folks and Java, and C# folks trying to look how much better C# is than Java.
Exactly.
So there was some fun kind of competition across different languages.
Cooked up a little bit. Again, it was not, the thing I was looking forward or to do so much, because it's just really hard to compare those things. And but yeah, of course, it's like everybody of course wants to show off that their favorite platform is like the fastest one, right? I totally get it.
So and you're running the kind of test for the challenge on a specific machine, so this gives you kind of, in the official competition, this gives you kind of pretty stable results. But one question I'm curious about here is what's the absolute minimum time to read a 13 gig file? What's the very smallest amount of time that this could possibly take?
Yeah, so my personal one, which is the baseline, and it kind of bugs me that I'm the last on the leaderboard. It's kind of embarrassing, I guess, but it is what it is. It's on purpose. So this one takes about 5 minutes. It's just the most basic thing you could do, like using Java streams, doing everything sequentially, not caring about allocations or whatever. So this runs about 5 minutes. So and nobody actually submitted one which was even slower. So that's good.
I think my Scala one was probably slower than that one.
So. Oh wow, okay.
I didn't even. Well, obviously it was Scala, so I could submit it.
But I think what you were asking was, how long does the operating system take just to load the data into memory?
Yeah, that's a good point. Actually, I designed this challenge for this to not be a relevant factor, because the way it works is every contender will be run 5 times in a row, and
so it's preloaded.
Yes, exactly. And then I will discard the slowest.
Caches the file, or
yes, exactly.
Is that all being read out of memory? And
you're running on a Linux system?
Yes, it is a CentOS stream environment. It has it's a very nice Epic server with 32 cores. Initially, I had a cloud box with dedicated CPUs, and I felt that should be all right. But then actually, apparently they moved this VM to another host, and when I came back the next day, all the numbers were off. It was way faster than before, so I couldn't compare it any longer.
The joys of virtualization and
exactly.
being able to move virtual machines around to other hardware. And
so I've had my fair share of learning about that stuff, and then I set up, with help from somebody from the community, which also was great. We set up a new dedicated box now. It's this super beefy machine. And actually, I run it still on 8 cores to, keep it a bit under control. If I do use all the 32 cores with hybrid threading, then the fastest ones right now run in less than a second, which I feel kind of crazy.
Amazing. That's amazing to read, process 13 gigs. Okay, so real quick, you run the test 5 times, you discard the slowest and the fastest, and then you average the 3 middle ones.
Exactly. Yeah. That's what I do.
Yeah, and so the fastest ones, from what I've seen now, are all like 2-3 seconds. Is that?
Yeah, so it's actually a few are below 2 seconds. Below 3 seconds now. So 2.8 or whatever. So it's really impressive. I'm not sure whether there is much more room. I mean, people really look at the assembly code which gets produced, and like there was this one guy. He's, oh man, I've been sitting here for 3 hours staring at the assembly, and I don't find any ways to improve that. Oh man, what have I done to this?
Can't eke out any more performance. One of the really good blog posts about this was the Rust version. So somebody created the Rust version, and they started with their kind of naive implementation and tracked how long that took on their machine. And then they started in the blog post, went through all the iterations of optimizations that they performed and how those optimizations changed things.
Right.
And then ultimately getting to this like 70 instructions on the CPU with no branching, and but really good blog post.
We have a few nominations or entries like that in the challenge as well. So people, for instance, Roy Van Reen, who's also one of the top contenders, he has a very extensive description in the header of his file where it describes all the steps he did. Thomas Wörtinger, for instance, he commented like how many CPU instructions his entry takes on his machine, and it's like really impressive to see. And also, I mean, just for me, I learned so much from that. It's really incredible.
Cool. And also, they all ran under Graal.
Not all of them, actually.
So the competitors could pick which VM.
Exactly. So because this also was one area I felt it would be nice to explore to see which kind of JDK distribution is advantageous, because I mean different distributions have like different GCs. As it turns out, you don't need any GC at all. You just can use Epsilon GC because you can implement it like without allocating so much. It would need GC.
GC has overhead that you don't need in this case.
Exactly. But then there's this distribution which has crack, like checkpoint and restore. So I felt it would be interesting to see how people play with all those things. And yes, also there's of course GraalVM working as the just-in-time compiler for the hotspot JVM. So that's what many people use. And then of course also native binaries compiled ahead of time. The most ones at the top, they use GraalVM either as JIT or as AOT compiler right now.
Yeah, so interesting to see the differences there. So let's talk about some of the different approaches that people have taken. So the naive approach, which you and I took, is read each line in the file and keep track with records or something similar. With the minimum, the maximum for each station, and then keep a total of the temperature so that then you can do the mean later.
Right.
And that's a good straightforward approach. Turns out it's not the most performant.
Right.
So let's talk about some of the approaches that people have taken. So I think one of the most obvious approaches is to not read the file line by line, but instead partition the file into blocks based on how many CPUs, and then multi-thread your file reads so that you get some parallelism there, and then aggregate all the results at the end. Am I understanding that?
Absolutely, yes. So that's what everybody does. I mean, that's the first thing which comes to mind, exactly as you say, to use as many cores as there are. So that's what everybody does. I would say there's just one challenge with that. You need to be mindful of the limits of those chunks, right? Because if you just split the file into, let's say, 8 equal parts, you might end up in the middle of a line.
You got to get to the end of the line somehow. So you got to make sure your partitioning is based on end of line, not somewhere in the middle.
Yeah. So
and I looked at maybe one of the implementations of this, and it seemed like there was the way they'd done it is with some attempt at finding a partition, where to partition, but then kind of adjusting the partition based on the character at that.
Yeah, exactly. So essentially, you I guess the simplest thing would be to go back until you go, back to the previous start of a line, and then this is where you end the current chunk, and then you start the next run off of that offset. I guess that's what I would do.
So, did anybody try? I mean, this is the first time I've thought about this, but there must be a way to do a running mean rather than keeping all the values. And I don't even know if that would help.
I looked at this and I could not find a math equation that would do the running mean. So
you can do it.
What would be an algorithm? I think you just have to keep track of the number of elements, and then you'd add one, and then do a redivide by that number.
Right.
That would be my guess. So it would be an algorithm rather than a formula.
So that's what most people do, right? So they keep track of the count. They keep track of the sum, and then they just divide the sum by the count.
Okay.
That's the simplest one. There is actually also an incremental way. I don't know the formula from the head of my mind, but you actually can incrementally compute a mean. I feel it would probably not be faster. I suppose just summing it up,
like having one make that big of it. It'd be more of a memory saving trick,
right? Yeah. And I think you got to be careful that you don't overflow if you do it the sum of all the values. That's the other thing.
Right. So okay, that optimization is pretty straightforward.
Right.
What's another optimization what's a bottleneck that people encountered, and then what's an optimization they performed?
Yeah, I mean, so there's two more things I think which are interesting to talk about. The next one would be like, how do you actually parse the line? So you have this chunk, and then in your 8 workers or whatever you do, you go through them line by line, and you got to find, let's say, the next line break. And the question is, how do you do that? And I mean, of course, you could just ingest or like iterate through the bytes and, go until you find the line break, and then you have found the line. But then there's better ways to do it. So there's one person did it with a very nice SIMD based approach. So they used this new vector API, and essentially they load the line, or let's say parts of the line, into one vector, and then, for instance, they apply like an equal operation onto all the elements of this vector at once, and that way they can find out that with one call whether there is a semicolon which divides the station name and the values. So they would be able to find that with one call. So, for instance, that's an interesting one. And this
like, is this like actually in Java that they're doing this, or how in Java do you actually do that sort of thing?
There is actually a new, or right now, what do they call it? Like a preview or an incubating API. It's called the Vector API. And this is, that's what it says, right? So it gives you an API for vector computation. And those methods, they are essentially backed by SIMD, single instruction, multiple data, CPU instructions, which you would have, like AVX2 or AVX512, this kind of stuff. And this is how Java makes exposes those instructions to you as a programmer. And actually, then if you run on a CPU which doesn't have a particular instruction, it would fall back to like a Scalar implementation. It would be slower then, of course, which I actually find fascinating, because, I mean, I'm not a big expert in C or whatever, but I believe there you would directly say which particular instruction you want to use, right? Whereas here it's actually, now it's portable, because the JVM takes care of mapping this to the right instruction on ARM, or mapping it to the right SIMD instruction on Intel. So I feel it's actually a very nice way for exposing those APIs to Java developers.
So let me ask, so with the SIMD instruction, in this case, the instruction would be, is this a semicolon? And it would simultaneously apply it to every
like 8 bytes or 16 bytes, something like that,
of the vector.
Okay.
Yes.
Okay. Huh.
That's cool.
All right.
So SIMD is able to essentially parallelize across multiple parallelize an operation across multiple pieces of a vector or something. Is that
exactly right? So you have, in addition to threads, and I mean, even taking a step further back, in addition to running on multiple compute nodes, you can run the same instruction parallel multiple times on multiple elements of your data, which just, I mean, ideally, it would be like, if you do it on 8 bytes at once, it could be 8 times faster, right? I mean, there's more to that, but that's the general idea.
Because you've read those 8 bytes already into memory registers or whatever, and so some CPUs have the ability to then apply a particular operation against all those registers at the same time.
Exactly.
Without having to use threads. And I think
it would also seem like there might be a stronger statistical likelihood of the semicolon appearing, not at location 0, 1, 2, 3 or whatever. And people make use of that.
Yes, they totally do. Also, and actually this, there is where my own, inexperience with doing this kind of thing shine through, because I totally did not expect people to take advantage that much of the particular data. So one example, I have this generator which produces this 1 billion rows file, and it has 413 or something different weather stations, which I took from Wikipedia, and this is the seed for generating this data. And in my mind, this is just one example, and people they should make this generator work. But then, like, everybody went straight and took advantage of, as you say, the characteristics. Hey, there's no name which is like shorter than XYZ characters, so let's optimize for that. It still would work with other data sets, but it's oftentimes it's very much optimized for the specific data set, which is fine. I mean, that's how the challenge is. I did not expect
the constraints of the challenge, but it's interesting. Like,
exactly.
there's a trade-off to optimizing for a particular data set versus a data set that you really don't know the structure of.
Exactly,
and you can make more optimizations the more constrained the input data would be.
Right.
So
and I guess
people did take advantage of like the structure of the data being somewhat knowable.
Yeah, I mean, and had I known that, or I guess next time I would design it in a different way so that people cannot optimize that much for a particular data set. I would just describe the nature of the data set, and then what actually is being used for evaluation. It would maybe be a secret essentially, but it's fine. And also, actually, so the official challenge is what it is. It uses this data set or key set with those 400 stations. But actually, I do like a side evaluation now, where actually have another generator which takes the whole range of allowed names, which is like 10K different names. So that's like the maximum number of stations which is allowed. And this also is interesting to see, because I occasionally run like the top 15 entries against that key set, and it shuffles the order quite a bit around. So some people have so much optimized for that initial key set, they go quite a bit slower for the larger 10K key set. And then there's others who do, I would say, maybe they are not the fastest, but they do really reasonably well for both key sets.
That's interesting to see the differences there. Well, and it's cool in your initial tweet about this that you mentioned SIMD. And I think when you mentioned it, you're like, I have no idea if anybody's actually going to like come up with SIMD implementations here. But
I was hoping it, but I did not expect it. There was another super interesting thing which I felt was really cool. So the temperature values, they are specified to be like between minus 99.9 and plus 99.9. So it's like 2 digits before the comma, 1 fractional digit. And one person actually felt, okay, this is just essentially 1,999 different values. So instead of parsing them, he created a perfect hash function, which allows him then to just do a lookup. So he just takes the bytes for the value, and then he does use this as an index to just get the value from an array. And that's a little bit faster. And I felt, okay, that's like a super creative technique. And it's just so cool to learn about, how people come up with this stuff.
Yes, I did see a number of entries using the like perfect hash map or near perfect hash map, and also on the station names of making some assumptions. I don't know enough kind of deep level things, but what makes using the hash for this faster?
Yeah, so there's a few things to be said for that. So first of all, the perfect hash for the station name, actually, it's not legal in terms of the challenge, because unlike the values, yes, there's only a specific values, but for the name, it could be there's a maximum length, but it could be any kind of name with 100 bytes length, essentially. So
you couldn't really have a perfect hash for that. Well, not within probably the reasonable amount of memory and so because there's enough variability in the names.
Should we explain what a perfect hashing function is?
Let's go there. Do you want?
Sure, I can. No, I can. So in a normal hashing system, it's like you're looking things up in an array, and what you do is you take whatever it is you're looking up and you hash it to a number, and then you just index into the array and then get the result. Well, the problem is when you do that, well, more than one thing can hash to that same number, in which case you have what's called a collision. And at that point, you create a little linked list and you say, okay, if we hash and we have a collision, we'll add to that linked list. And then when we're looking up, then we hash, and then we have to hunt through that linked list. So, and then you look at that and you go, oh, but what if you never had to step through the linked list? You'd have a much better, it'd be much faster. Well, the only way to do that is to come up with this function that has no collisions at all. And then you always know, and the only way you can do that is by constraining your basically constraining your data set to something that and then your function can say, all right, it'll never have a collision.
So one of the implementations I saw with this said, we're probably going to see all of the stations in the first 100,000 records. And so we can construct our perfect hash from
and that would not be actually like a legal entry into the challenge. Unfortunately, it's not like really possible to test for that, because like you would have to create hash collisions, and I don't know what kind of hashing scheme they would even use. So that's a matter of like looking at the code, and I'm sure a few ones slip through. But this is definitely not what you should do. And if I realize it,
assumptions
then it would be
like how would you test for that? I'm not sure.
Exactly. So I mean, I could do some sort of random testing, and hope it would spot collisions. But how long would you do that? So actually, so if I and again, people. This actually, I need to tell this. People were super supportive with just running the challenge. So as I mentioned, there was one guy, René, who helped me a lot with just setting up this new environment and configuring it and so on. There was another person who helped out with creating all those kinds of tests. So we actually have like a small TCK, which you need to pass now to be a valid entry. Yeah, and
people somebody send a pull request, you can actually like do some validation to see
exactly right. So
actually like doing following the rules as best we can determine.
Right, and so one of them, for instance, is you need to pass a test with 10K different names. So this already would weed out those who would have used a perfect hash, which just works for those 430 stations. And then actually I still because so many people have their custom hash structure. Part of the pull request template is so if you do use a custom hash function, please point me to the point in the code where you deal with collisions, so that I can take a look and see whether it's implemented in a meaningful way.
Evaluate it if it's if it could possibly have collisions. So rather than trying to come up with the test to validate that, you're looking at the code to make sure that their collision code is it fits with the rules.
Exactly. And again, I'm sure, there might be a few ones which have slipped through. But again, to me, it's not that much about it. Still, those people who may accidentally have used it or have like a function which actually has some collisions, I'm sure they still have learned a lot from participating and doing this. So for me, that's totally fine.
Yeah. Did you try running any of these through like Chat GPT or something to have it evaluate?
I have not.
But tell me if this
is reasonable, or are there any bugs in this algorithm?
No, I have not done that. But actually, one participant, and you may know him, and Antonio Gonçalves from Spain, one of the Java champions. He just earlier this week, I still need to get back to it. He put in an entry which he created using Google Copilot. So in the PR, he shares like the prompt history, how he created that.
Awesome.
And I suppose it's not very fast, but if it's valid alone, I mean, that would be pretty impressive, I would say.
Right. Yeah, I mean, if he could get within some near performance of some of the top ones and not having to have really written code or maybe even understood the code, that definitely indicates something about the future of AI in our industry.
Yeah.
So should we talk about code complexity and maintainability?
We do need to talk about that. Before we get there, I want to see if there's any other kind of big optimizations that people utilize. So we've got optimizations for parallelism of doing things in parallel. We've got optimizations for parsing the lines more efficiently. And then was there any other like big buckets of optimizations?
So I wanted to talk about mapping and how do you do this aggregation. We touched on that. So people come up with their custom array-backed map implementations, essentially. So that's what many did. And then actually over the last few days...
This is about, the optimization here is about not doing memory allocations. Or doing very minimal memory allocations. Like, let's do a memory allocation on the aggregation for each station the first time we see it. And then we're just going to perform the fastest updates we possibly can on those bytes in memory for the aggregator part.
Exactly. And how you keep track of that structure, right? So if you get another entry for Hamburg or another entry for Crested Butte, how do you find that aggregate as quickly as possible that you can add the latest measurement to that one? So that's what this is about.
So what were some of the approaches for doing that kind of efficient lookup of where the aggregator piece is? Is this like, is there a data structure, or the people using unsafe? Like what's the
we also can talk about unsafe because that's what happened over the last few days a lot. But yes, on that one, I think what most people do is they take an array, they try to find a hash function which works on the raw bytes. So, you want to avoid like creating a string. So you work on the raw bytes, and they use a hash function which works, reasonably well for the specific key set. And then to deal with the collisions, as Bruce mentioned, essentially they do what's called, I believe, open addressing. I'm blanking right now. But essentially, if you go to this spot in your array and there is something already, then you need to compare its name. So that the structure there must have the name of the entry. So you compare that. And if it is not the name which you want to add to, then it's something else. And then essentially you keep going in that array until you find the next free spot, or you find your entry which has been created already. So I think that's the implementation most people chose.
Yeah. And this is using unsafe, or is unsafe a further kind of optimization?
Right. So for unsafe, I think people mostly use it to actually get the values out of this file, because actually we didn't talk about that. So you want to memory map the file, so you can access it from native memory. And then most of the top entries right now, I would say, use unsafe to interact with the memory mapped file and get the values out of it.
Okay. So in Java, there's an API to memory map the file and partition. I guess partitioning, after you partition or when you partition, whatever, memory map it, and then you want the fastest way possible to read the bytes out of that memory map. And unsafe gives you an API to do that super efficient reads out of the memory map. Is that?
Yeah, that's correct. That's exactly right. And actually, this also touches on what I mentioned. There's this new API for foreign function and foreign memory access. So, it also lets you deal with off-heap memory. And one of the limitations people always complained about was that you only could have 2 gigabytes of a memory mapped file. So in this case, with the old APIs, you couldn't memory map the entire 13 gig file at once. You would have to chunk it somehow and then, memory map those sections. Whereas now with this new foreign memory API, you actually can just get the entire thing, which just makes it a bit easier to work with, I would say.
Nice. And then one other thing that I saw come up was around GraalVM's auto vectorization.
Right.
Do you know any more about that? I didn't understand all that.
To be honest, no. I'm a bit out of my depth there. So it seems in any case, it's fair to say that the GraalVM JIT compiler is a good fit for this problem, because most people just used the GraalVM JIT compiler, and it just gave them a little speed up. So apparently, it works well for this problem. Unless the one guy who did this super interesting stuff with this new vector API, because this one is not yet optimized in the GraalVM JIT compiler, so it doesn't make good use of those instructions, and actually then it's a bit slower on GraalVM.
So, and I guess my my take on my understanding of the auto vectorization piece is maybe that GraalVM, which I think is only in the like Oracle, not the Community Edition one, is that it can do that vectorization for you without you as the developer having to do the vectorization. And is that all just the SIMD vectorization stuff we were talking about earlier, or is this a different kind of vectorization?
Maybe both. I'm not sure, to be honest. I'm not quite sure about what GraalVM would
so maybe
would
some
do there.
Fascinating automatic optimizations that GraalVM can do with auto vectorization that wouldn't require the developer to have to explicitly specify those.
I mean, one of the things I totally want to do is do like a podcast like this, or get some live stream set up with like, a few people who contributed. Like I would totally hope Thomas would be there.
That would be a really fun podcast series, because interview the top contenders
and because those guys can talk much more than I could to those particular implementation details.
Cool. Okay. Any other interesting optimization techniques that you ran across? Or
I think that's from a high level, I would say that's it.
Cool. And amazing that people did all this within Java. I mean, going from you and I's kind of naive implementations, which took like 5 minutes, down to 2.5 seconds is pretty freaking amazing what people are able to do with Java. So that's cool. Okay, so now let's go back to Bruce's question. So I think maybe that's a setup for this, is that the naive implementations are readable to, you can read the code and understand exactly what problem you're solving. I first read your baseline implementation and was like, oh, like every piece of this makes sense to me. And looking at these highly optimized versions, the things that are in those is now like incomprehensible to me. Maybe there's somebody that understands those, but I think there's this huge trade-off. It's like, do you want to do things in the expressive way, or do you want to do things in the performance way? And there's this giant gap between those in terms of the code maintainability, the code readability. And I don't know, to me, it's still an unfortunate piece of our developer world, is that there is such a big gap. Is that
it's hard to know whether it's a solvable problem too. It's like anytime you introduce optimizations, you take an impact on, A, the cost of developing it in the first place, and then B, maintaining it. And both of those things, the cost is going to shoot up. So you want to do this really judiciously.
Totally. And I mean, one thought I have on that, I totally agree with you. It's very interesting to see. But what I also observed is actually, I feel it helps to think about it in terms of orders of magnitude, because what I found is, if you look at the implementations, which, for instance, run, I don't know, like in 20 seconds or something like that, so one order of magnitude faster than my very naive baseline, you will find entries there which are equally, maybe even better readable than what I do. I mean, they do the parallelization, they do, they just don't do like the stupid stuff. They avoid like obvious things would avoid. And so you get to that space, I would say, with perfectly readable, perfectly maintainable code. Again, I think it's better than what I did. But then the next order of magnitude, so now like
you go off a cliff.
Exactly. Then it's getting completely out of control, and it's not something you would want to have in your regular enterprise app code base. I guess it's okay to have it in the JDK somewhere. But so I felt that's the way I think about it.
Yeah, I guess that's a good perspective. Is like likely you've got the naive approach that is, the baseline that you and I both wrote, and there's some very obvious places where you can get an order of magnitude faster without having to get into the like crazy stuff.
Exactly.
Without obfuscating your code.
Exactly.
That's a good.
But without, and I feel like I've struggled with this in Python because you have it really clear, and then you start worrying about performance, And at some point, you need to stop and use the foreign function call interface, which has always been terrible until Rust came along. And then, but you only want to do a little bit. You only want to do what's necessary to speed it up, and then you can call out to that, and then you balance. You keep your code reasonable in both languages, but pushing a language beyond its limits of understandability just seems like a really risky and potentially very expensive thing to do, because if the original developer is gone, which is not unlikely, who else do you know? Somebody even understands the domain.
No, I think you really want to contain this, and I don't know, have some, maybe, I mean, if you, let's say you were to work on a finance application or whatever, right? Maybe you would create like a kernel of those calculations which do this super optimized stuff, and it's like really super contained. Like for every line of code, there's like 10 lines of comment and so on. And that's maybe how you would deal with it. And you only would do it there, right? And then you would try to like do the normal thing in like 99% of your code
But
base.
I wonder, maybe I could be wrong about this, but my experience with people who are really good at writing that kind of code are not really good at commenting that kind of code. I think
know.
there may be a disconnect there that makes it inevitable.
It turns out writing comments for really complicated code is really hard.
Right.
Yeah. I mean, check out the entry from Cliff Click, who also is one of the fastest ones. He actually did a great job at commenting it. And I mean, I'm not saying that I go to it and like I read it from top to bottom and, oh yeah, sure thing, I totally get it. But I think, if you or I or anybody else would sit down and spend some time with it, I think it would start to make sense. I feel it's not like terrible.
Yeah.
Mm-hmm. Huh. Well, and he's someone who writes and explains. So
exactly.
Yeah, and I guess that's the thing you have to do. You go, okay, if we're going to do this terrible thing, we need to get somebody who can, do it and explain it and create maintainable code, and that's a rare commodity.
Yeah. Yes. And he did even, so he has this, what is it called? The Compiler Coffee Club or something, like his own YouTube or streaming format, where he actually walked through his implementation. So this one is there's even a YouTube video about it.
Oh, nice.
You can check out.
I'll find that and put that on the show notes.
And you made this all happen in a couple of weeks. That's just...
Yeah,
the explosion. It's like, boy, if you push the right button, if you can find it.
Yeah. And I mean, I keep thinking why it is, and I feel one reason is because it's such a deceptively simple problem. I mean, you explained it like in one sentence, right? So like everybody gets it. You can talk to like anybody about it, and they will understand the purpose of this, or like the target, what you should do. But it's still at the same time, it opens up so many possibilities, right? And I feel this just like nerd snipes all those people. Man, I want to see how fast I can do it, and somehow it's just at a sweet spot there.
I'm sorry. Did you say nerd snipe?
Nerd snipe. Yeah.
That's a good term. Good phrase.
Yeah.
It's an official term, right?
Yeah, it's a good term.
One other interesting thing I think on this topic of the trade-offs between expressivity, what's the being able to express the problem most clearly in code, clarity versus the optimizations, is that we did certainly see that the JVM and GraalVM in particular has incredible benefits that it's providing to the developer to do optimizations for the developer. And I think this has kind of always been in some ways the case for having a JIT and a JVM, a VM in some way, is offloading those optimizations to the VM and letting it handle those in the best way that it can. I think some of the challenges there is that a general JIT and VM doesn't always know the best path to optimization that it should take. And so if you want to get to that next order of magnitude, that's where you've kind of reached the boundary of what things can be done through that abstraction layer. And it takes the human to then, take it to that
or a
next
large
level.
language model.
or maybe a large language model.
Yeah.
But certainly, I think the use of GraalVM shows that yes, there is optimizations that the VM and JIT can do for you, and that has a ton of value to getting to that like middle layer of of performance.
Yeah. And I mean, so are you talking about now GraalVM, the JIT compiler, or GraalVM as in AOT compilation?
I think both. I think there's probably different optimizations that they can each do.
Right.
I should ask you about the PGO one, because that was an interesting one that Thomas on the GraalVM team had done initially. Was using profile guided optimization. So GraalVM has this way where you essentially like run something, and that then tracks what is being done in the program into a profile. And then when you create your final native image executable, in the case of GraalVM, it uses that information to perform the optimizations more accurately.
Wow.
So essentially like what a JIT is doing over the course of an entire runtime of a program, but it does it into code. Exactly. And so I don't know what happened with the PGO version. I don't know if it was
I asked him about it because he mentioned it initially, but then he told me that he has done everything like manually already, so that PGO just wouldn't.
So he didn't need PGO because he'd done the optimizations manually. But interesting use case, I think, for again this point of like maybe with PGO you wouldn't have to manually write all the optimizations.
Right. Yeah. Exactly. Yeah.
So, and I think I've seen some of the latest data from Oracle where they feel like generally with PGO they can get the ahead of time outputs to be almost as fast as the JIT over time, which is pretty impressive results. Because the challenge with ahead of time is that you don't know what to optimize.
Right. Yeah. And I mean, it's not for the platform. Yeah. I mean, I haven't compared myself, but it seems like it's really getting there. So definitely, it's interesting to see for sure.
Yeah. Oh, cool. Any other things around this that we didn't touch on?
No, I mean, I wanted to say, again, thanks to, obviously to everybody who participated, and it's open, right? I mean, it's running until the end of January. So, I mean, some people said on January 31st, exactly, they want to, come with their super amazing entry on the last hour. So we will see if that happens. But yeah, so thanks for all the people who participate. Thanks for all the people who helped running it. Actually, this was super amazing for me to see because, as I mentioned, right, at some point I had like 60, 70 pull requests, and I didn't know what to do, and then I had to move this environment, and it was like really, I was overwhelmed with it, and people just came and helped, and there was one guy who did like all this evaluation scripting, so now it's like really easy to run this and get the numbers and update the leaderboard and everything. So this was super inspirational.
He really rallied to like help you scale the whole challenge, which is amazing.
Exactly. And then people ask, so hey, are you gonna do another one? So what do you do like next January? We will see. Right now I think I definitely will need a break from challenges after January, but who knows what's gonna happen next year, right?
Well, and what you've learned from this you'll probably take
exactly,
and feed into the next one.
Definitely. Yes.
And so you have a whole year to be kind of looking around,
recover.
Recover, and then it's sort of a background process,
right? Yes, no, totally.
Puzzle, and it could be something completely different.
Absolutely, yes. And I think it would for sure be better defined. That's something I learned for sure. So people wanted to know about all those constraints and what is this whatever legal and so on. So I would have to do a better job in like really precisely defining it. I would have to make sure that the particular data set is not as known as it is right now.
Right.
So it would have to be a bit different.
Yeah. Mm-hmm. And then I think you kind of got to the point where where the fastest ones were close enough to each other in terms of performance that it's a little bit hard to differentiate which one is exactly. Really kind of faster because the threshold between them got so small.
Exactly.
So then I think we're in a Twitter thread around, does this need to be like the trillion row challenge and create like a larger differentiation?
Absolutely. I just was not expecting that people would get to like below 3 seconds. I mean, this was like beyond what I would have assumed. And yes, exactly, on that environment and with the way it is set up, I just cannot measure like if it's like 10 milliseconds difference. This is like the background noise, I would say. So it's just for me not. I cannot tell then, okay, this one is faster. So actually now we have like a shared first place right now.
Because they're like close enough within their threshold.
But actually today they're not. I just ran one earlier today, which actually is a bit faster, and I would say it's clearly enough faster that I would put that one on first place now.
And the highest speed is still just shy of 3 seconds.
Yeah, so this one which I had today was like actually 2.5.
Okay.
And I want to have the other guys at the top to take a look just to make sure like nothing is like wrong with it. But it seems it would be the fastest one with something like 2.5.
There you go. The leaders get to evaluate the submission.
Yeah, I just feel more comfortable doing that, to be totally honest. Because again, all this code is like super dense, and it's also not what I usually would write. So I mean, who am I to say this is like correct or whatnot? So I asked those guys, so hey, if you have some time, maybe you also can take a look. And actually, for instance, I had one. This was also interesting. I had one. This looked super easy. It looked super well maintainable, and it was super fast. So this was like on the readability level of like 1 order of magnitude faster, but it ran like on the order of 2 orders of magnitude faster. And I just felt, no, something is wrong. This cannot be. And so I asked Roy, hey man, can you take a look at this one? It looks so good. It's so easy to comprehend, but it's so fast. I feel something is odd with it.
He was only reading one every 10 rows or something.
Yes, exactly. It was exactly that. There was something was off, and it actually just processed a subset of the overall data set. That's why it was so fast.
It's one way to optimize.
Exactly right. Yeah.
So it's interesting on the readability front, because the challenge really was about performance, not about readability. But the hard thing with measuring readability is like it's like beauty; it's in the eye of the beholder, right? And so
exactly.
And so like it's just so hard to look at these, and like I feel like when I look at them, I can be like, oh, I can really read that one, but it depends on my knowledge, my the way that I understand things.
Totally.
But I do wonder if there's some way to like, would it be possible to have some element of the challenge be readability, but maybe it's just way too subjective. Maybe
that's what I felt. Somebody also asked. Yeah, but some people asked about it. Hey, can there be like a special prize for the most readable solution or whatever? How do you evaluate that, right? And I mean, what I find the best readable may be different from what you would prefer, and I just feel it's like not like objectively.
It entirely depends upon your background and what you are used to.
And maybe Cliff Glick would say his implementation is perfectly readable, right? So I mean, you also have to accept that.
To him, it is. Does the winner get any prize?
Yes. So that's also an interesting thing.
Digital badge.
I mean, they get the honor of being on the top of the leaderboard. But initially I had planned to just for the winner to create a T-shirt and just pay for it out of my own pocket and send it to the winner. But actually now, and I have to plug my company or my employer Decodable. They agreed, and we will do something, and I don't know, do a couple of T-shirts for the top N. So I'm still figuring this out. So there will be something.
Yeah. Well, that's cool. They'll get something to wear at a conference and
exactly
show off their work.
A conversation starter.
Yeah. I would probably buy a T-shirt just as like I don't know, like if you had like a T-shirt that you could buy that's like not like.
So maybe I should set up a store where
you could actually like fund some prizes through selling T-shirts or something. But
we have a T-shirt now too.
We do,
yes,
for Happy Pest Programming.
Oh, okay.
But it's not a fundraiser. It's just a T-shirt you can buy if you want.
Okay.
Pretty beautiful. I think.
I need to figure this out. So once everything is like the official challenge is over, I will have to figure out how I go about it.
Yeah,
but there will be something.
Yeah. Awesome. Well,
Cool.
Gunnar, thanks for joining us. Super fun. Thanks for
Absolutely.
all the work that you did to run this contest, because
that you accidentally created.
Yeah. Sometimes I second. How do you say? I question my life choices. But
yeah, I can see that.
The accidental going viral.
I was just
no, but it's fun, and I mean, so many people reached out and just said, "Hey, thanks, this was really cool," or "I learned a lot from it," and I mean, that's the best thing I can.
What a cool thing to help people learn new things. So
exactly.
Thank you for doing that.
Absolutely, it's a pleasure.
Awesome. Well, thanks, Gunnar.
Thank you so much.